Alright, you are accessing this video because you are struggling a little bit with the worksheet Still Mastering Our Own Domain. This was assigned to you guys so that you could practice more with finding the domain of a function, giving its algebraic representation. I'm going to work through just a couple examples, and I'm only going to choose the ones that seem particularly relevant and ones that kind of address different things each and every time around. So I'm going to go ahead and work through number 1 first. Actually, you know what we're going to do? We're going to go ahead and do 2. Nah, forget it. We'll do 1. Alright, so we'll do 1. And I'm going to go ahead and do 1 in black. So the function I had here, well, have rather, is f of x is equal to x minus 2 over x squared minus 6x plus 9. Now, the common mistakes that folks make with finding the domain of a function is they try to think of all the things it could be. The more efficient way to go about this is assume it can be everything and then pick out the things it can't be. So I always draw a little picture first. So I draw a number line, pardon the hideousness of this number line, and I'm going to assume that the domain is actually going to end up being all real numbers. So I like to draw a little number line over top of that. Wow, these are really spectacular lines. You'll have to forgive me while I'm figuring out how to use this bamboo pad. So these are all the real numbers, and the red part is the actual domain of the function that we find it, well, that we discover it to be. Alright, so I'm going to assume all real numbers. We'll assume everything works. Now, obviously what I'm not allowed to have happen is divide by 0. So whatever's happening here in the numerator is completely irrelevant, so I actually don't need to pay attention to that at all. So we can just kind of ignore that. We're just going to kind of focus on this. And what we can't have is dividing by 0. So we just need to find the places where this denominator is actually 0. And we'll pick those out. So we'll have x squared minus 6x plus 9 is equal to 0. What I'm going to go ahead and do here is try and factor. So we're going to say there's a 1 here. And this is the way that I tend to factor. Not everyone does it this way, but this is the way I do it. So I multiply 1 and 9, multiply the outsides, and I get 9. And what I want to do is find factors of 9 which add up to negative 6. And I call those my magic numbers. So they need to multiply to 9 and add up to negative 6. Well, it's pretty clear here that those numbers are going to end up being, well, number is going to be negative 3 and negative 3. Alright, so now what I end up with is this x squared. And what I'm going to go ahead and do is rewrite the middle part to have those magic numbers instead of just that one term, minus 3x plus 9. And that's going to equal 0. So now I'm going to factor the GCF out of that, and I get x, and I'm left with x minus 3. And you're going to have to pardon the scratch out there. And then we're going to go ahead and do minus 3, because I could pull a negative 3 out of this, and I have x minus 3. Alright, and that's going to equal 0. So my final factorization, x minus 3, equals 0. Well, you're going to have to pardon the speed of that factorization because I'm assuming we know Algebra 2 because we're in pre-calc. So now I know x minus 3 squared is equal to 0. Therefore, x equals 3. Alright, so here's what I know. I know 3 is something that can't be in my domain, because if 3 is in my domain, then what I have in the denominator here is 0. So then I'd have this green thing, who cares, whatever that is. So bleh, we'll say that's in the numerator, who cares, divided by 0. And that's not okay. wow, can't even do a frowny face. That's not okay, so we can't have that. So what I need to do is go into my number line. We'll say 3 is right here. And what I'm going to go ahead and do is pluck that right out of my domain. So I can have everything that's not 3 in the domain, and I'm in a good place. Nope. Turn that on. So if it's not 3, it's allowed. Now I'm going to write the actual domain here. So here the domain, well, if I can be everything that's not 3, I can be one of two things. I can be everything before 3, right? So I'll do that set in blue. So I could be everything here, right, going all the way back forever. So it would basically end at negative infinity, and I'm just going to write this in interval notation because I think it's the most straightforward way to do it. Up to 3, and not including 3. It's really important that we remember we're not including 3. And then we'll do everything after that in pink. Okay, I can do everything after 3, which would mean I'm starting at 3, and I'm going all the way up to infinity. Now I just need to kind of put a cap on it here. I need to, since these are two parts of one unique set, I use a union, and x is somewhere in this set. And this is our solution. So now I go up here, and it looks like D is my winner. That's the domain of this function. Okay? So that's how we set out to do kind of the first flurry of problems. This is really just kind of, if you ignore this whole first part, it's really just a whole bunch of problems that we're getting ready to do in the second examples, like here. I'm really only going to focus in on, well, you know what, I'll do them both. Number 8 first. All right, so with number 8, there's two things we have to consider with the function d. I'm going to do 8 in black, obviously. Well, with this function here, I have a radical with an even index. It's really important that we remember that the index has to be even to create the possibility of something to exclude from our domain. Because if it's an odd index, being the little number here, if it's third root or fifth root or whatever, then we don't have to worry about it at all, because we can have negative numbers under those and we're totally okay. And we have a division, so we can also have a division by 0. So the first thing I'm going to go ahead and do is look for the division by 0. I mean, that's the most obvious thing to find. So we'll start there. So if I'm dividing by 0, then what we're really talking about here is 4x squared plus 4x plus 1 has to be equal to 0. Because obviously the only thing, when I take the square root of it, that gives me 0 would be 0. So now I'm going to go ahead and factor this using Algebra 2. Factor or quad formula. And I'll leave you to your own devices on that one. And what we end up with is 2x plus 1 squared is the factorization, so that equals 0. So then 2x plus 1 has to equal 0. So x is negative 1/2. So now if I think about my domain again, right, then what I have is this list, right, which is synonymous with all real numbers. I'm just assuming that I can put all real numbers in there and I won't have a problem. Okay? But I know at negative 1/2 I've got an issue here. So I know I have to pluck out 1/2 or negative 1/2. I know that that's where I'm going to run into a real snag. So I just have to be aware of that. Boom. Alright, now what I need to check, and the second thing we always need to look for, since we have this radical with an even index, I need to consider this. Obviously, if there's not a division, I don't need to worry about division by 0. So then what I need to do is look for the negatives under the radical with even index. Alright, so now what I need to know here is 4x squared plus 4x plus 1. When is that actually going to end up being less than 0? Well, alright. I know that that just basically rewrites to 2x plus 1 squared. When is that going to be less than 0? Well, here's the thing. If I go ahead and like take the square root of both sides, then now I want to know, well, I don't even have to do that. Think about this. If I take a number and I square it, right? This is called algebra without algebra. Some number squared being less than 0 means that number has to be negative, right? And that's actually not possible in the real numbers. Okay, so n can't be a real number if this is true. So really, at this stage in the game, what we're saying is this isn't possible. It's actually not possible. There's no way that if I take some number and square it, it's going to end up being less than 0 if that number is actually real. Okay? Which is a little bit of a strange idea, but it makes sense if you think about it. Because if we looked at the graph for this thing, right, we'd be looking for places where it would dip below the x-axis. Well, since there's only one root, right, that means the vertex would touch here at -1/2, which means it would do one of these jobbies. And it would never go below the x-axis, so there's no negatives that would ever be under this radical. So it's not possible, so the only thing we have to do here is exclude -1/2. So my final result here, I would say, just like I did in the last problem, everything before -1/2, not including it, and everything after -1/2. Oof. And not including that. Let me fix that up. And obviously I need to make sure I have proper convention, because believe it or not, convention is really important. If we can't express our answer correctly, then really what's the point in even having it? It's like if a tree falls in the forest and no one's around to hear it type situation. Okay, so that takes care of number 8. And generally speaking, I mean, if you need to set the algebra up like this, and you need to solve the equation that way, that's totally one way to do it. I really encourage you to start thinking about the graphs and start thinking about the functions and try to find ways to where you're being more artistic than being hard-working. I guess ultimately there's kind of a slick way to do things, and then there's kind of the brute force way, and I want to see you guys try to learn a little bit of sleekness in your procedure. Alright, for number 9, I'll do number 9 in red, just so that it's very clear. And this is actually starting to confuse me a little bit, so let me try and stay organized. So I've got the fourth root of x squared minus 10x plus 21. I'm going to have to pause this for a second. Alright, looks like we're getting close to announcement time, so we may get interrupted at some point, but that's alright. Alright, here, for the division by 0, we don't have to worry about it because there's no division. So we're good. So now what I need to do here is find where we have the negative numbers, because we now have a fourth root. So we need to find where this is negative. As stated before, this is a quadratic. So what we know, okay, and this is just some arbitrary sketch, is this thing here, and we know it actually opens up, right? So what we're looking for is, if it does something like this, we need to get rid of this part here in our domain. Okay, so that's what we're looking for. So let's find where that actually happens. Let's find the roots. Okay, so I've got x squared minus 10x plus 21. I'm going to assume we know how to factor. And after we factor this thing, what we end up with is x minus 3 and x minus 7. So the zeros are at 3 and
Juniors, you
7.
are now dismissed. Come on down to the large commons, meet the football team, the cheerleaders, and listen to the band. Juniors, you are...
Alright, so here's what I know. I know that I have a parabola. It opens up, and its roots are at 3 and 7. Right? So all of this stuff in the middle here, I know I'm going to have to get rid of. So, I'm going to go up to 3, and I can actually use 0 at this point. I can have 0 under there. So I know I'm going to have 3, and everything to the left of 3, and 7, and everything to the right of 7. So now my domain. I'm going to go ahead and do my final result in black so that it's clear.
Sophomores, you are now dismissed.
So now,
Sophomores, come down to the large commons, greet the football team.
alright, so now I know x is going to be from negative infinity up to 3, and I'm going to use a bracket this time because I can totally include that point, and it can go from 7 to infinity. Alright, I hope this was helpful. I know this is definitely one of the longer ones I intend on making. If you have any questions, still come and see me for tutoring.